Welcome to another episode of Physics Astronomy Guys. I'm Ian.
And I'm Alan.
And today we'll be talking about ferrofluid and what it's made of and some theories about how the spikes are formed.
Ferrofluid is essentially just a magnetic fluid, as its name would imply. It's made of three main ingredients. There are the tiny nanoparticles. A nanoparticle just means an extremely small particle. They're made of either iron, nickel, or cobalt, or potentially gadolinium, any of the ferrous metals. And then there's the surfactant, which holds on to those nanoparticles and attaches them to the medium, the third main ingredient. And the medium just essentially adds volume and makes it a liquid.
Okay, and the pictures you're seeing right now show two balls of spikes on both ends and then kind of a smooth part in the middle. Well, that's because the magnetic field lines run directly from the North Pole to the South Pole along the edges, making it smooth. And it's only on the poles where the magnetic field lines go out where the spikes form.
So essentially it ends up being perpendicular to the fluid, parallel with the poles, but then it's parallel with the fluid when it's parallel with the poles. And so the smooth area represents the part in between the North and South Pole.
This ferrofluid that we used is made up of iron nanoparticles and mineral oil as the surfactant.
So this here is on a white tray. You'll notice that on the edges it's more darkly colored. That's just where the fluid kind of remained and some of the mineral oil escaped from the nanoparticles, I suppose.
This is when we put the neodymium magnets up to a bolt. And because the bolt is made out of metal, it kind of acts as an extension to the magnet.
Magnetic field lines, or really any waves for that matter, tend to transfer better between materials that are similar. So you'll notice that if you have an explosion underwater, there's not as much transfer of energy out to the air. For the same reason, when you have a magnetic field that's from a metallic material, and then you place it up against another metallic material, the magnetic field is going to transfer through to the bolt. So the bolt is acting like the magnet in this case, and so you'll notice that you still get the spikes to form on the bolt, but just past the bolt, there's not going to be very strong magnetic fields.
So the leading theory on why the spikes are formed is because of gravity and surface tension.
The idea is that because they're seen to form along the field lines, it's thought that the magnetic field is strongest there, and that surface tension and gravity restrain it, whereas the magnetic field pulls some of the nanoparticles out to form that conic-like shape. But that does rely on the axiom that it's strongest about the field lines, which doesn't seem to make very much sense to us because field lines don't actually exist. They're an abstract concept. They're made just to illustrate what the field looks like, but there aren't really areas where it's strongest.
And so we're doing a little research right now to try to figure out more about how the spikes are formed and how ferrofluid reacts in different temperatures and such. Okay, we're approaching the end of this video, and so I want to give a thanks to Jim Harrison. He's the person who took all the pictures for us of this ferrofluid. So thank you, and goodbye.